This is the experimental setup for the open circuit characteristic of a DC shunt generator. So this is a motor generator set. Motor and generator is mechanically coupled. So on the left side we have motor, and on the right side we have the generator. So both motor and generator has mainly two parts in it. One is the armature and the other one is field windings. Okay. So we have a rheostat, that is a 140 ohms rheostat that is connected to the field winding of the motor, and a 50 ohms rheostat that is connected to the armature of the motor. Okay. So what we are going to do now is bring the motor to rated speed so that the armature of the generator will rotate. Okay. And slowly allow current to flow through the field winding, and we are going to see how the voltage is going to build up. We are not connecting any load across the output of the generator. Hence, this is actually called open circuit. Okay, so generator is actually open circuited, and the characteristic that we are going to find out is actually called open circuit characteristics. So ultimately what we are going to find out is what is called as the critical resistance. Okay, the critical resistance of the generator is what we are going to find out. Okay, so we can find out the critical field resistance of the generator by plotting the open circuit characteristics. Okay, so we have two graphs. One is called as VG increasing and the other one is VG decreasing. Alright, we'll start the experiment now. So keep all the rheostats in their respective position, that is initial positions, that is 50 ohms is in cut-in position, 140 ohms in cut-out position, and the 750 ohms that is connected to the field winding of the generator should be kept in cut-in position. Okay. So 750 ohms in cut-in. So 750 in cut-in, 50 ohms in cut-in, and 140 ohms in cut-out. Okay. So now switch on. So the motor starts rotating. Now we need to bring the motor to rated speed. So vary 50 ohms rheostat slowly. So the speed increases gradually.
1298, 1324, 1332.
So vary it fully.
1361,
Fully.
1382, 1414, 1439.
So the rated speed is 1500 RPM. So we have completely varied 50 ohms rheostat. Now we need to vary 148.
455, 1499, 1550.
1500. Bring it to 1500. Reduce it.
1600, 1582, 1567, 1554, 1538, 1527, 1516, 1507, 1502,
Okay, done.
1400.
So we have brought the motor to the rated speed. Now there is a switch which is connected to the 750 ohms rheostat. So we need to close this SPST switch. SPST switch. Okay. Now we need to start varying the rheostat little by little and take down the readings. So vary the rheostat. So when the rheostat is brought to cut-out position from cut-in position, you can see the gradual build-up of the voltage little by little. Very. Little more. So you can see that the voltage is increasing little by little. Okay. So at regular intervals, you can increase the voltage little by little and go up to around 200 volts. Okay. Up to 200 volts at regular intervals. Note down the voltage and the current. Okay. This is for VG increasing. So once you're done with the increasing voltage, you need to take down the readings for the decreasing voltage. Okay. So for that, you just have to go in the reverse direction, little by little, gradually cut in the 50 ohms rheostat and note down the current as well as the voltage across the generator. So you can take down one reading here. So at regular intervals, you can take down the readings. So now it's the reverse procedure. Remove the switch, bring the 140 ohms to cut in position and 140 ohms to cut out position, 50 ohms to cut in position. And then open the circuit. So after completion, when you plot the graph, so the graph will look something like this. Touch my lip. Yeah, okay, this is fine. So the graph will look something like this. Okay, thank you.